Now we have 10 deployments and services for our microservices, where we have almost the same attributes with just different values. So wouldn't it be great if we could just have one blueprint for both deployment and service for all 10 microservices and just be able to set the values for these individual services? Well, we can do exactly that using Helm charts. In one of the previous lectures, you actually learned about Helm and about Helm charts, and you learned that one of the main benefits of using Helm charts is to define reusable Kubernetes configuration, and microservices is one of the best use cases for that. Now, there are two ways of creating Helm charts for microservices. First one is creating separate Helm chart for each microservice, which makes more sense if the microservice configurations are very different from each other, or the second option is creating one shared Helm chart for all the services. Both of these ways have their advantages and disadvantages, and which option you choose really depends on your application. You can actually use a combination of both. If you have a bunch of applications that are very similar, for those we can use one single chart that they can share and then pass different values for each individual service. And if in addition you have a handful of applications that are different and have a different configuration, for those we can create separate charts to avoid overcomplicating the main Helm chart. In our case, the configuration is almost the same for all the services, so we're going to create a shared chart for all our microservices. So back in our online shop microservices project folder, we're going to create a Helm chart using a simple Helm create and then chart name command. So let's call our shared Helm chart, which all microservices will use, just microservice. And let's hit enter and let's see what happens. So as you see here, a microservice folder appeared. So that's our chart. And if I expand it, we have a couple of auto-generated things inside, which we can go through one by one. So it's a pretty simple structure actually. So first of all, we have this chart.yaml file, which basically describes the chart metadata. These are the chart name, description, chart version, application version, this kind of data. So this is where we can set all these values about the chart metadata. We also have charts folder, which basically holds any dependency charts that this chart might have. In our case, it's a simple chart. We don't have any dependencies, so this folder will stay empty. We also have this .helm ignore file, which defines a bunch of hidden folders or hidden files from different code editors, version control tools, etc. So basically this file tells Helm to ignore all of these folders and files when building a package archive from this chart. Building a package of the chart is not what we're going to do here, but just so you know, Helm charts can be built and packaged and distributed just like any other artifacts. So you can build a Helm chart into an archive and basically host it on a Helm repository. So that's what building a package means, and that's what the Helm ignore file is for. And then we have templates folder, and this is actually the core of the Helm charts. So this is where most of the work on the Helm charts actually happens. So if I expand this templates folder, you see a bunch of files that some of them actually named just like Kubernetes YAML files, right? We have ingress.yaml, deployment.yaml, service.yaml, and so on. So this is where we're going to create Kubernetes YAML files, or at least the blueprints of the Kubernetes YAML files. And if we look inside one of them, like service.yaml file, you see that the attributes are actually same as in the Kubernetes service configuration file. However, instead of the actual values for some attributes, we have this syntax with double curly braces and some expressions inside. So the values with this weird syntax are actually placeholders to the actual values. So these are like defining variables in your YAML file, which you can then replace with actual values. And this here is actually called a template. So it's not a valid Kubernetes YAML file as is, it's just a template, right? Where we need to actually fill those values. However, we are gonna write all the template files that we need from scratch and get rid of all these auto-generated files. And this way you can learn the basic template file syntax from scratch. So what we're gonna do is simply mark everything inside except for deployment and service YAML files and simply remove them. So in templates folder, that's all we have. And we're gonna remove the contents of these two as well. So we're gonna start with a clean state and write our template files from scratch. So that's our cleaned up templates folder. And finally, the last file among these auto-generated stuff is values.yaml file. So this is a place where the actual values are set that will be then substituted in the templates file. And again, we're just gonna clean this up. We're gonna write our values file from scratch. Awesome, so we have everything ready to get started. So what I'm gonna do is I'm gonna actually paste in the basic deployment file that we used as a starting point for all our microservice configuration. And which looked like this with a bunch of X's or placeholders here for the actual values. So that's the file we're gonna start with, and same for the service. And this is actually pretty much the structure that Helm chart template files use. So you have a bunch of attributes and all the values that are either repeating and all the values that we want to dynamically set will be basically represented with placeholders instead of the actual values. So let's create a Helm template file from this. So to set the variables in template file, we use the syntax of double curly braces as we saw. And then inside that we have .values, the name of the variable, then we can decide ourselves, like any variable name. So that's the basic syntax of how to create a placeholder variable in a template file. Now, where does this values object actually come from? Or what is this? Well, values is actually a built-in object, which by default is empty. But when values are defined in the values.yaml file or in user-provided values.yaml file or passed onto Helm using the set option on a command line, then all these values from these three different sources get injected into this values object. So that's how we can actually access anything defined here in a custom values.yaml file that we create in addition, or values that we set using -- set option. And Helm actually uses a couple of built-in objects. This is one of them. And by standard, all built-in object names actually start with this capital letter. However, our own objects or variables, we can actually name them whatever we want. However, there is also a standard of naming variables in Helm charts, which is a camel case format. So not dashes or lowercase values, but rather camel case. So basically that's the format we use. And as I said, values object gives us only what we define. So obviously whatever we use here, we will have to then define either in values.yaml file, in the default values.yaml file right here, in a custom values file, or using a set attribute. So the first variable we will define is app name. So this is going to be the application name, like email service or payment service or whatever. And obviously we can use the same placeholder or same variable for every place or attribute where this app name is used. So the deployment name, pod label, and selector for that label. We can also use it as a container name for simplicity, and we can also use it in the service, right? Name the service, because our service has the same name as the deployment and pod, and same selector. So in addition to having a blueprint for multiple microservices, you see that this additionally gives us an advantage of not repeating the values even in the deployment and service files of the same microservice, right? So instead of defining the actual value like email service 5 times, 4 times here and in service as well, we can define that actual value once outside in one of the values files and then just reference it using the same variable name, like app name. And it means if the application or service name actually changes, we would just have to adjust it in one location. Awesome, so let's continue. I'm actually gonna copy and paste it here, and let's call this variable container port, like this. And this is actually the same value that we're referencing in the service using target port. So we can just go ahead and paste in the same variable name right here. So whatever the value is of the container port that we set later will be the same here in the target port and container port. Awesome. We can also define the service port like this, because these two actually can have different values. So we can set it differently. And finally, for the service configuration, we can actually make this value configurable as well, because we have one microservice, which is front-end service that actually has a type load balancer and not cluster IP. So we can make this configurable so that different types of services will be allowed. And we're going to call this service type. And this actually completes our service configuration. And you see that writing a basic template file is super easy. So let's complete the deployment YAML configuration. So we need an image here. Now, image has 2 parts, right? We have the repository and image name, and then we have the image tag or image version. And we can actually allow configuring them separately. So how do we actually reference 2 variables for the same attribute value? So let's say we have an app image here, and now we need an app version. Well, so we would need something like this, right? So we have app image and app version separated by a colon. So for this to work, we just have to enclose this into double quotes, and that's it. So this will be interpreted as an actual colon string. So the image name and version name or version tag colon separated. And this will give us the full image. Another thing that we also want to make configurable is a replica count, right? Because we want to let the users of this Helm chart decide how many replicas of each microservice they can run. So how do we do that? Super easy. We just add the replicas attribute here, which if we do not specify by default is 1, but we make it configurable. So app replicas, and that's it. As long as we provide the value for app replicas, the replica count will be set. Now there's one thing that I want to point out here. There are different ways of defining the variable names. I told you that the variable names themselves are in camel case. However, in Helm, you can actually define those values in hierarchical structure. So you see that we have a couple of attributes here that start with app, right? So app name, app replicas, app image, etc. So one way of defining this could be like this. So we have not one value like app name, but rather hierarchy like app.name and app.replica. In which case, instead of defining the variables like this, you can define them hierarchically like this. So both of these approaches are possible. However, Helm itself recommends using a flat hierarchy like this instead of a hierarchical structure, especially where you have multiple levels of objects. That's why we're actually going to use these flat variable names like this, because that's actually the best practice. And the reason for preferring this over complex value objects is that it will make it simpler for the template users to define the values, especially when using the -- set option. So our deployment file looks good. However, we are actually missing the environment variables because all our microservices actually define at least one environment variable, some of them even more. So we have to define them right here. So we have env, name of the environment variable, and the value. So for a single environment variable, we can have container env var and key and value like this. So if we copy and paste this here, we will also set the value in the same way, just like this. However, we want to set multiple environment variables and we want to make them configurable. So if one microservice has just one environment variable, that should be set. If another one has 10 environment variables, that should be handled as well. So how do we express that in a template file? Well, for working with a list of something, in our case, a list of environment variables, we actually have a built-in function in our template files called range. As you know, in programming, we have this concept of loops whenever we're working with lists. So range basically is the same thing. It loops through or ranges over the list of variables or objects and lets you access each element of that list one by one. And the syntax for range is also pretty simple. We have, again, our familiar double curly braces, dash and range. That's the name of the built-in function. And that function basically takes the list variable as an attribute. And we can call that container env vars. So that's going to be our list. So range function will basically go through this list and give us access to each element one by one. So this way we can access the key value pairs that we define in the container env vars list. Again, we're going to see how to set the variable values in a later section, but this is how we define the placeholders. Now, there is one more thing we have to do here for the value itself, and that is the environment variable values are always interpreted as strings, right? So even if we have a port name as a variable value, which we have for our microservices where we define the port, it has to be quoted, right? Like this. So even though this is a number, a port number, it is quoted because the environment variable values are always strings. So how do we make sure that this value will be set as a string? Well, for that, there is another built-in function called a quote. And for that, we're going to use syntax of piping that you probably already know from the Unix syntax of piping the input of one program into another. So that's a similar concept here. So we basically pipe the value into a built-in function called quote. So we quote whatever the value of this environment variable is. And finally, we're gonna close this loop or range by doing end. And that's it. So this basically lets us or other chart users define or provide any number of environment variables, doesn't matter if it's 1 or 10 or 0, to this deployment file. And that's exactly what we want. So that's the syntax for our template file for deployment and service components. And now we need to actually set those variable values. And as I said, one place to define the default values for all these variables is the values.yaml file. And this actually could be generic because obviously this is something that we're gonna override for each individual microservice, because every microservice has its own specific configuration that we're gonna override. However, with the default values file, let's actually see how the variable definitions will look like. So again, this is a simple YAML file. So we use a YAML format. App name will be the service name of the microservice. Then we have app image. This is going to be the image that we have defined in the deployment file. For us, we're using Google's public microservices demo, so we can copy this from the deployment file here. So this is the location of the image followed by the service name. We have the app version. This will be the version tag that the application has. We have app replicas. We can set it at 1 as a default. We have container port. By default, we can set it to 8080 or any other value, it doesn't really matter. And we have container env vars, which is a list of environment variable key value pairs. So how do we define that? In YAML, we express the list using dash, and here we have the key and value, right? So they have to be called exactly as we reference it here. So this is going to be key env var 1 and value 1. And then we're going to have key 2 and value 2. So that's basically how the values for deployment template will look like. For simplicity, actually, we can change these also to name so that we can directly copy the values from our config.yaml file. And there you go. So these are for deployment template. For the service template, we actually define the values in the same values.yaml file, right? So if we had 10 different YAML files here for 10 different Kubernetes services, we would define the values of all those services in one file, which is actually pretty good because for the values that we use in multiple Kubernetes YAML files, we can just define it once here and all the components can reference it. So here, let's set the service template values. So these are already defined, app name and container port. And now we need to define service port. Let's also make it 8080 by default and service type. And of course, let's make it cluster IP as a default. So our template definitions are ready. Our default values are ready. Obviously, these are not the actual valid values, but these values would actually be substituted in all those placeholder places. But obviously, we want to set the actual valid values for one of the microservices instead of the default values. So how do we actually do that using a custom values file? Well, pretty easy actually. We're going to create our own values.yaml file, and this could be anywhere, usually outside the chart itself. So I'm going to create it here, and I'm going to call this email service values.yaml. And I'm going to copy all this, and I'm going to now start substituting the actual values for email service. So let's take the app and substitute it here. Then we have the version, replica count 2. The container port is the same. We can actually leave it out because it's already defined in the default value, or just for transparency and visibility, we can leave it explicitly stated here. We also have all these environment variables, and because we called it name and value in the variable itself, we can simply copy and paste it here. Fix the indentations, and then we have the service port and service type. The service port, we have 5000, and service type is a default So we can actually remove the service type definition, so this value will be used. So basically everything that we define here, every attribute, will override the attributes here. Whatever we do not specifically define will be used from the default values.yaml. And we're going to save it. An email service microservice can already be deployed using this Helm chart. So how do we actually validate that our template files and the values that we define are correct? How do we check that we are producing valid Kubernetes YAML file? Well, we can use Helm commands for that. Helm template, and we're going to pass on our email service values YAML file, and we're going to need the chart name, which is microservice. And let's see what comes out. And we already see an error in deployment.yaml file line 21 because we need a space between those two. So we have dash space and then range, and let's try again. And there you go. This time it worked, and template command actually doesn't execute anything. It just gives us a nice preview of the template filled in with the actual values from all the values sources, right? So this is one source of values for all these attributes. So we have the target port, the app name, replicas, which is 2, the image name and version, environment variables, and then we have the service type, which we didn't define here, which comes from the values, the default values.yaml file, which is cluster IP. So our configuration file for service and deployment actually looks pretty good. So the way it works in the background is that when Helm evaluates a chart, it will send all the template files that are defined in the templates directory through Helm's template rendering engine. The engine will then replace all the variables or placeholders in those template files with the actual values from the values resources, which are the default values file, user provided values file, or --set option, which we can use to override single values defined here, for example, like app replicas 3. Helm will then collect the results of rendering of those templates and send those files to Kubernetes when we execute Helm install command. Apart from Helm template, we also have something called Helm lint, which actually checks the correctness and validity of your YAML files and gives you an output whether you have any errors in your charts. So this is a way to validate your syntax. So now let's see how we actually deploy the email service microservice into the cluster using this Helm chart. So our Kubernetes cluster is empty. I have deleted all the previous microservices. So let's install our chart. So we have Helm install command, which you're already familiar with. Then we will provide our email service values.yaml file. Then we provide the release name, which is basically the application name that you're deploying into the cluster. In Helm world, this is called creating a new release, right? That's why release name. And this is going to be email service. And finally, we need the chart name, right? That we're using to make this release, which is our microservice chart name. And this command should install our chart. And if we do Helm ls, we see our email service microservice running as a chart. And also, if I do kubectl get pod, I have 2 replicas of my email service running in the cluster. Now, obviously, using a Helm chart to deploy only one Helm release or microservice isn't very valuable. Of course, we need to deploy all the microservices with it. And now that we know how to install one microservice with a Helm chart, let's deploy all other microservices as well with the same Helm chart, which is very simple. All we need to do now is basically just copy and paste this custom values file and fill them with values for all the microservices. So let's do that now. Let's close the microservice chart folder, and I'm gonna copy this, and let's go through them one by one. So let's do recommendation values.yaml file. And fill the values. So we have recommendation service right here, 2 replicas, has the same container port. Then we have all these environment variables. And the service port, which is 8080. And the service type is the default cluster IP value, so we don't have to set that here either. And let's create another one for the product catalog. Product catalog service values. Name of the service. The container port is different. We have the environment variables. And the service port is different. And we can actually put all these values in its own separate folder. So we have a cleaner structure because we're going to end up with 10 of these values files. So I'm going to create a values directory and let's put them all in there. So I actually went ahead and created all of these values files for the rest of the services as well. So we have the payment service, for example, that has 2 environment variables, which you can see right here. Then we have checkout service with a bunch of environment variables. And final one that we're going to create is frontend values.yaml. Container port is 8080. Then we have all these environment variables again. Like this. The service port is 80. And here we need to define service type because it is not the default cluster IP, but rather load balancer. And there you go. So we have values for all the microservices defined here in the values folder. So basically the idea is that you create these template files once, and then you can just work with these values to basically customize the configuration files for different environments like development, testing, and production, and or for different applications, like in our case, for multiple similar microservices. And obviously we could now install each application using the same chart and a different release name and a different values file. And this file now is inside the values folder, so we need to run helm install with this as the location. So this will deploy the recommendation service release with 2 pods that are running. Now, you probably already noticed that we don't have a Redis definition here. And I left it out on purpose because Redis is actually not the microservice we develop ourselves. It's a third-party service that one of our microservices, which is cart service here, is using. It has a very similar configuration, so we could deploy it using the same chart, but again, because it's a third-party application, the lifecycle is different from our own microservices. It means that we want to separate that from all these services, and to separate it, we can either deploy it separately using the Kubernetes configuration file that we already have for Redis, basically just taking these two components here, or we could also create its own Helm chart for the Redis service. So let's create a separate Helm chart for the Redis cart service. For that, I'm actually going to create a parent charts folder here. And I'm going to move the microservice chart inside. So we're going to have both charts in one place. So I'm going to cd into the charts, and the same way as we created the microservice chart, we're going to create the Redis chart. So helm create Redis. And if I expand this, you should see Redis chart was auto-generated with all these values. Again, we have the chart metadata here. We have the templates folder with all these files we can clean up. And we have the values file, which we can also clean up. So I'm going to create deployment.yaml file here and service.yaml. And I'm going to paste in the full deployment.yaml file for Redis, as well as full service.yaml file with the actual values. And we're going to reverse engineer it now and basically remove the values, the actual literal values, and make them placeholders to create our template files. So first of all, obviously we have this repeating Redis cart value in all these places. So we're going to make this configurable as app name, just like we have it in the microservice chart, and basically replace it everywhere, including the container name. Let's call it the app name as well. And there you go. Let's make the replica count configurable as well. App replicas. For the image, I'm just going to copy what we have configured here. So as you see, the configuration is actually pretty similar in the charts. We can also copy the container port, which we'll also make configurable. Service port. We can leave the type to cluster IP hard-coded because chances are we're not going to expose Redis externally because that's not a good practice. So let's leave it like that. And here we're going to add the port details to our health checks. So here for the liveness probe, and then again for the readiness probe. And additionally, we can also parameterize all these volume and volume mount attributes. So let's say the volume name can be defined by the user of this chart. They can call the volume whatever they want. So let's call the variable volume name. Again, this is the value that repeats, so it makes sense to replace it with variable. And we can also make the path configurable. Let's call it container mount path. Awesome. So we basically parameterized almost everything in deployment, YAML file, as well as service. And now we can set Redis values as well. And note that for a Redis chart, I can also define the values in this values folder. It doesn't really matter where the values file is defined. It could also be sitting outside this repository. But with this structure, we basically have all our charts for one project in the charts directory. So even though they're separate, we have them in one place. And all the values for all the charts in here can be defined in the values folder. So it gives us a nice structure. So let's call these Redis values.yaml. So we have this Redis values file, and we have the default values file where we define all our values. So let's set them one by one. App name Redis by default, app image also Redis. This is default, so it's probably not going to change. Then we have the app version, Alpine, app replicas 1, container port, and this is the default Redis port, so we're going to set that in the default values.yaml file. We have the volume name, Redis data, and the container volume path. So these are all the variable names we defined, and set its value to /data, which is also a default path for Redis for storing data. And finally, we have the service port for Redis, which is the same as container port. So these are all the default values. And let's say we want to override the app name and replica count in our custom Redis values file, which means we only have to define those two values. Everything else will be taken from the default values.yaml file. Again, let's validate our Redis chart. So Helm template, we pass the Redis values file, and then we have the charts / chart name. So let's see. This is a result of the template rendering engine, which basically filled our template files with the actual values, and all this actually looks pretty good. We have our image here, our volume configuration, ports, and 2 replicas. Another way of previewing that our manifests files are actually valid is by using Helm install. And we pass in an option called dry run. And all the values that Helm install would normally take. The values file and the chart name and the release name here, like Redis cart. And this will actually also give us a preview of what will be installed in the cluster. So the chart will not be executed, but it is going to give us a plan of what's going to happen.